Okay, so here we have two very similar situations where we have a 5 kilogram mass that's on a table that's hooked up on a pulley to another force. Okay, there's another force that's acting to the right. So we're going to break down system 1 and then compare it to system 2. Now, whenever you have two objects that are connected, you're going to have to create a negative and positive side. Okay, the right side is always going to be positive, and the left side it will always be negative. Alright, so here we have a positive force of weight, since force of weight is the force that is pulling down, and then we're going to have a negative tension, since tension needs to be opposite whatever this force of weight is. So here, the object is going to have a positive tension. Okay, so we're going to keep flipping our signs as we go. So system 1 has a 20 kilogram mass or object that's connected via a rope to a 5 kilogram object. Assume there's no friction. So actually, if we were to draw a free body diagram or a force body diagram for this 5 kilogram mass, in the x direction, there's no friction. All you've got is tension. Okay. Anyway, how much force pulls down on the 20 kilogram object? Well, the force pulling down is the force of weight, which is equal to mass times gravity. Well, mass is 20, gravity is 10, so that's a force of weight of 200 newtons. Alright, then it says if the 20 kilogram object had nothing attached to it, what would be its acceleration? Well, if there's nothing attached to it, like this rope on the top, well, then it would be free falling. Its acceleration would be 9.8 meters per second squared downward, okay? Or in two-dimensional motion, we call that negative 9.8. What is its maximum acceleration, or what is the maximum acceleration of system 1? Well, since that is by far the greatest acceleration that this 20 kilogram mass can have, the system cannot accelerate any faster than the acceleration due to gravity, which is 9.8 meters per second squared. As the top mass gets bigger, does the acceleration of the system increase or decrease? So what it's saying is this 5 kilogram mass, if it got bigger and bigger and bigger, would the system's acceleration increase or decrease? Well, it would decrease. Even if we're not changing the frictional force, if there's no friction, there's no force to oppose it, but still, our acceleration is going to get smaller and smaller and smaller. Why? It's because we have the same amount of force being applied downward, but now we have more mass. As the mass increases, we're going to have more inertia in the system, more resistance of these objects to move, so the acceleration will decrease. Okay, then it says calculate the acceleration and tension in this system. So we need to treat these objects separately and do our sum of the forces, so sigma F equals ma, for each one. Well, this one is acting in the x direction. This box will be moving to the right. So we want just the forces in the x direction for this guy. Well, since there's no frictional force, the only thing that we've got is tension. It's positive, and that's all we have. So tension equals mass times acceleration. Okay, well the mass is 5. So T equals 5a. For the second mass, we have force of weight, which is positive, minus tension, which is negative, and that's going to equal mass times acceleration, where the mass is 20, and we are trying to solve for acceleration. Okay. Well, if we know that T equals 5a, we can just sub 5a for T here. We know the force of weight for this 20 kilogram object is 200, because 20 times 10 is 200, minus, and then remember we're taking this 5a, which is equal to T, and subbing it in. Okay, so we can move the negative 5a over, so add 5a to both sides, and we know that 200 will equal 25a. So if we divide both sides by 25, on the right side it cancels out, and on the left, 200 divided by 25, should realize is 8 meters per second squared. Now, once we have our acceleration, we can calculate tension. So we know that tension is 5 times the acceleration. Well, mass is 5, acceleration is 8, therefore the tension will be 40 newtons. there is our acceleration and tension. Alright, for the second problem, it says system 2 has a 20 kilogram mass replaced by a 200 Newton force. So this person, okay, it says it's Jim here, so Jim is going to apply a 200 Newton force downward, okay? Now notice that the force of weight for the 20 kilogram mass up here is 200, which is equal to the force that the person is applying. Okay? Now, how much force is on the rope now? Well, we're pulling 200 newtons on the rope. Okay, as Slim Jim pulls harder and harder, does the acceleration of the system increase or decrease? Well, if he pulls harder, it's going to increase. The force will become more, therefore the acceleration will become more. What is the maximum acceleration of the system? Well, really, the maximum acceleration depends on how fast and how hard he can move this string downward. So really, it's infinite, okay? Or it's how hard the guy can pull. Alright, so we can actually surpass 9.8 meters per second squared, which is the greatest acceleration that the first situation could have if the object was just falling. Alright, so it says calculate the acceleration and tension in the system. Well, for this, we assume there's no friction again. We just have tension to the right. Okay? And we also know, since the force on the rope is 200 and tension is the same throughout, our tension equals 200 newtons. We also know that the sum of our forces, and well, in this direction, that is the only force we have, equals mass, which for that object is 5, times acceleration. So we can actually solve for acceleration by saying 200 divided by 5 is 40 meters per second squared. Okay, notice that that tension, 200, is much greater compared to the original, which was only 40 newtons, and that the acceleration of 40 meters per second squared is much greater than the acceleration of the first one, which was only 8. Okay, why is it different? Well, what happened in the second situation is we made this mass go away. It was 20 kilograms, but we made it go away. So there is less mass, which means there is more or less inertia. If we have less inertia, there's going to be less of a resistance to get these objects to start moving, which means we have more acceleration. Remember, Newton's first law, the law of inertia, means an object in motion will stay in motion and an object at rest will stay at rest. The only thing that affects inertia is the mass of the object. The greater the mass, the greater the inertia. Notice that when in the second system we had less mass, we had less inertia, so it was easier to accelerate.